Hi, IB. We just wanted to make this a 7C video so that you had something to just kind of support you as you guys are working through your trigonometry and just getting back into what you started in year 10 and just basic understanding. So just want to bring you back to three shapes that we have worked with a lot over the years. So consider this first shape to be an equilateral triangle where the sides are 2, 2, and 2. So 2 units on each side. If I split my equilateral triangle in half, all right, about like so, what I'm going to wind up having is the base is now going to be split into 1 and 1, and I now have a 90-degree angle. So now I have one length of 1, the hypotenuse is 2, which would make 1 squared plus what squared is 2 squared. So now I have this root 3 as the height of my triangle. And again, an equilateral triangle has values of 60, angles of 60. So if this were 60 degrees, then, and this is 90, then this corner would be 30. And there is my 30, 60, 90 triangle, where the side length ratios are 1, root 3, there's 1, and then 2. All right, so if we focus less, I guess, on memorizing and thinking where do these values come from, it all starts with the equilateral triangle with side lengths of 2. If I do the same thing with a square, and I cut my square in half, and again, we want to use really small values because for every equilateral triangle, we'll have a similar ratio for the side lengths. So you can make this triangle as big or as small as you want to, but the side lengths are all going to be the same ratio. Same with a square. I can make it as big or as small as I want to, but we're going to keep it easy, and we're just going to make a square with sides of 1. So if I have a 90-degree corner, and I have side lengths of 1, then 1 squared plus 1 squared is going to wind up being square root of 2 squared. Okay, so my hypotenuse is square root of 2, 1 and 1. If this is 90 and I split each corner in half, this is going to wind up being 45 degrees, and this is going to wind up being 45 degrees. So there's my second special triangle, 45, 45, 90, where sides are 1, 1, and square root of 2. So these ratios just come from shapes that we use, and we've been using for years. We're just trying to learn a little bit more information about them. All right, guys, so last but not least, we've been talking about this circular motion. So if we start to look at our unit circle and we say that, let's say we look at a circular motion such as a Ferris wheel. If we get on the Ferris wheel at this initial point, all right, we have our degree is 0, and we only have, if we were to describe the position of this point, we have an x value, but we have no y value. So our point would be at 1, 0. All right, as this point travels around the circle, so in a counterclockwise motion, let's say it stops right about here, where the angle is about 45 degrees. Okay, so if my angle is 45 degrees, we now know we can call this pi over 4 for 45 degrees. And basically what happens is if this is a 45-degree triangle, it is proportional to this 45-degree triangle, which means I can fit it right here. So if this is my 45, 45, 90 special triangle, the same proportions as we saw from the square, when I describe the x value, which we now are talking about as my cosine because it is adjacent over hypotenuse, and in this unit circle, we're going to reduce our hypotenuse down to 1, so that my radius is a 1 unit. So my cosine value is going to be just as if I were standing here at this 45-degree angle. Adjacent is 1 over hypotenuse, square root of 2. All right, so 1 over square root of 2 gives me my cosine value. So if I were to talk about this point, I would say that 1 over square root of 2 is my x value or my cosine value. And then if I talk about the height, the sine of theta, which is of 45 degrees, that is, if I was standing right here, opposite is 1, hypotenuse is square root of 2. So again, my sine value is 1 over square root of 2. Now I could find a decimal equivalent to 1 over square root of 2. And basically, if I move from my origin to the right, 1 over square root of 2, and then I move up, 1 divided by square root of 2, I wind up with this new point P that has started to travel around my circle. And what we notice is that as we travel, so let's say the point stops here. All right, if I were going to describe the position of this point, my triangle, as my point goes, so let's say my point stops here for a moment, notice your triangle is going to get skinnier and skinnier, okay? And eventually it's going to flatten out as we come here. So I have no x value, but I do have a y value. So I've got 0 for x, 1 for y. And then these same triangles are going to repeat as the point travels to 180 degrees. So this same blue triangle that I made over here at 45 degrees, I could make it over here. Okay, same exact 45-degree triangle. I drop it down to the x-axis, so it makes a 90-degree. So I would have the same x and y value, except now my cosine is negative because I'm going left. So if my cosine is representing the x, I'm now going to have a negative cosine value. So I'll have negative 1 over square root of 2, but my y value is still positive, so 1 over square root of 2. All right, so any triangle that I wind up matching for an angle in the first quadrant is going to repeat in the second quadrant. However, now my x values or my cosine values are negative, but my sine values are positive. So this whole idea of watching this point travel, so here this point can stop in the third quadrant, and I can make the same matching triangle from the origin. So here would be my 45 degrees. There's my right angle. My cosine is negative, and now my sine is negative. So I'm going to have negative 1 over square root of 2 and negative 1 over square root of 2. And then as I travel to the fourth quadrant, same 45-degree triangle. Here's my point as it continues to travel around the circle. Okay. I now have an x that's positive because I'm going to the right, and then I'm going down to get to this point. So I have 1 over square root of 2 is positive, and then negative 1 over square root of 2 is my y value. So now let's think back to what happens when we get here at 180 degrees. So my x value is at negative 1, my y value is at 0. I come down here to 270 degrees. I'm going to wind up being at 0x and negative 1y. Okay, so my cosine would be 0, my sine would be negative 1. So lastly, what we were talking to you about today was that tangent is opposite over adjacent. So in this case, it would be sine over cosine. So if I want to talk about any of my tangent values, I'm looking at my sine value divided by the cosine value. So for example, at 270 degrees, sine divided by cosine would be negative 1 divided by 0, and that would be undefined for tangent because I can't divide by 0, right? So I can do this for any of the points around the circle. So let's see how this plays out with some of your examples from the textbook. All right, so for a few questions in the 9C, I'm just going to help you guys set these up, and then I'll let you guys check and make sure that you understand and that you get the right answers with the textbook. So just looking through A, part 1 and 2, the very first part of it says, state the exact coordinates of A, B, and C. Now we're in a Cartesian coordinate plane. So again, sine, cosine, and tangent are all positive in the first quadrant. Sine is positive, tangent is negative, and cosine is negative. So only sine is positive in the second quadrant. In the third quadrant, Cosine's negative, sine is negative, and negative divided by negative is positive. So tangent is positive in the third quadrant. And then in the fourth quadrant, cosine is the only one that's positive. So you can think of this as all of them are positive, only sine is positive, tangent is positive, and cosine is positive. So maybe all students take calculus, or all stops, all stations to Chatswood, all right, whatever is the easiest for you to remember. If we are going to be asked to state the exact coordinates of A, for example, well, point A is at 26 degrees. The x coordinate is going to be cosine of 26 degrees. The y coordinate is going to be sine of 26 degrees. Okay? If I'm going to write this, so I've already checked off part I, state the exact coordinates in terms of sine and in terms of cosine. So that is cosine 26 degrees as my x value, sine of 26 degrees as my y value. If I'm going to use my calculator to give the coordinates of A, B, and C correct to 3 significant figures, I would need to make sure my calculator is in degree mode. So when you open a new document, make sure that your calculator is in degree mode under settings, because you can also be in radian mode. But since we are entering a degree, make sure we are in degree mode, and then you should match this 3 sig figs that are in the back of your textbook as well. So pretty basic setup for this first question. We just need to understand that to write a coordinate in terms of sine and cosine, just like this point B here, we would be writing cosine of 146 degrees. Now notice 146 degrees is in the second quadrant, so this should come out to be a negative value. And then sine of 146 degrees is going to be a positive value. All right. Whereas when you get down to C, both should be negative. Cosine's negative and sine is negative. So just make sure that you're understanding that as you're going through, and we're not just writing down things that our calculator gives us. Our calculator is only as smart as what we tell it to do. All right, so there's a hint for your number 1. Go ahead and try to set up all of these points as well as in part B, and use your calculator to see if you can round off to 3 significant figures. So an example here, start a new document in calculator. If you go to doc and you go to your settings, document settings, right now I am in radian, so I would have to make sure that I go to degree and then push OK. Okay, so now I can wind up putting in sine, which is under trig. So sine, and that was, oops, the first one was sine and cosine of 26 degrees. So sine of 26 and cosine of 26 degrees. All right, so now the calculator recognizes that I'm putting in degrees, and it will give me the exact answer that I want. For number 2, it says, with the aid of a unit circle, aka your plate, complete the following table. So for example, at 0 degrees, this is when my point has not moved at all. So think about your circle. I'm at 0 degrees. Here's my point. So 0 radians as well. My sine value is my y value. So remember, we labeled this point earlier as 1, 0, because I was going to the right one unit, which is the radius of the circle, and then staying there. So my sine value would be 0, because that's my y. Cosine is my x, so that's 1. Tangent is sine divided by cosine, so 0 divided by 1, which is 0. Let's do one more. If my point travels around the circle and stops at 90 degrees, remember this is pi over 2. Okay, my sine value now is 1. My cosine value is now 0. And tangent is sine divided by cosine. Well, 1 divided by 0 is undefined anytime I divide by 0. All right, so just to give you a hint, So work your way around the circle and see what happens at every interval of 90 degrees. When you're working on number 3, you'll notice that the back of the book has all of these values written in as a decimal, and they are decimals that wind up being equivalent to 1 divided by square root of 2 and square root of 3 divided by 2. Notice that those values came up when we were talking about your special triangles. So square root of 3 over 2, and 1 over square root of 2, which all wound up being your ratios for your two special triangles, 30, 60, 90, and 45, 45, 90. So let's try to fill in this table without reducing them to a decimal or changing them to a decimal. Let's try to use these actual values here. So again, radians, let's just start with a couple of these. Radians for 30 degrees is pi over 6. And so if I were looking at 30 degrees, I'd be looking at this 30, 60, 90 triangle. And I'd be trying to fit that 30, 60, 90 triangle into my unit circle. And here would be my 30 degrees. Here's my right angle. So now I'm thinking, well, I remember my triangle. The ratios for the side lengths were 1, root 3, and 2. Okay, so if I were to work with sine, if I want to find the sine of 30 degrees, sine is opposite over hypotenuse, which would be 1 over 2. Cosine would be adjacent over hypotenuse, that would be root 3 over 2. And tangent would be opposite over adjacent, or 1 divided by root 3. Okay? If I were to move my point to 45 degrees, I'm just going to sketch a new circle for a moment. So pretend like my circle is on this axis. And here's my 45-degree triangle. So there's 45 degrees, there's my right angle. And the ratios for 45-degree triangle are 1, 1, and square root of 2. So again, this is pi over 4. And my sine is opposite over hypotenuse, so 1 over square root of 2. Cosine, same, 1 over square root of 2, which would make my tangent opposite over adjacent as 1. Okay, so I'm going to wind up using these two triangles as I go around my unit circle. So at 60 degrees, I'd be doing the same thing, but from a reference point of 60. So here would be my triangle, 60 degrees here, 30 would be up here, 90. So now my side length ratios just wind up rotating around my circle. Here's my 1, here's my root 3, and here's my 2. All right, so these two special triangles can just be rotated to fit as the point travels around the circle. All right, so go ahead and try the same idea for the next few values. So the last question I'm going to do with you guys is number 6, because this really reinforces the whole idea that, oh boy, I should have made that straight, that if you were given, let's say, sine of 43 degrees. So let's say 43 degrees is about here. All right, here's 43. So again, I'm traveling around the circle. My point leaves and it stops about here on the circle, which is at a 43 degree angle. If we say that sine is 0.6820, which is the ratio of the opposite side length over the hypotenuse, then it's asking you, what would be the sine of 137 degrees? Well, notice that 137 plus 43 gives me 180. So really what they're asking me for is if you basically replicated the same exact triangle in the second quadrant, this angle, starting from 0, would be 137 degrees, which would mean that this angle inside the triangle is 43, which is the same as this first triangle that I drew. So both of these triangles are identical. They're both lined up with the x-axis. However, this one is in quadrant 1 and this red one is in quadrant 2. If I notice my sine value, they're telling me, is 0.682. 2, 0. Sine value is my height. So the question is, did my height actually change when I went to the second quadrant? So my height really stayed the same. What did change, though, is the cosine value, because the x is now negative in the second quadrant, whereas my x was positive in the first quadrant. So for part A, I don't need a calculator to figure this out, because it's going to be the same answer. Okay, so sine of 137 is also going to be the same as it is for the sine of 43 degrees, which is 0.6820. However, if I take a look at something like, let's say, cosine, let's look at C. Okay, cosine of 143 degrees. So let's see, I'll make a new diagram. They want me to figure out what cosine of 143 degrees when they give me cosine of 37. So here's 37. And now I'm going to 143. So I'm going over here to quadrant number 2. Same exact triangle. So this is still going to be 37 when this angle is 143, since they add up to 180. However, my cosine value does change from quadrant 1 to quadrant 2, because this was a positive cosine value, where now I have a negative cosine value. So if I were to write down the cosine of 143 degrees, I wind up with negative 0.7986, because I've moved from quadrant 1 to quadrant 2. So take a look at the other values and see if you can recognize what would change. Would it stay positive? Would it stay negative? Or would it switch signs? All right, we'll take a look at a few more of these after break, but hopefully this is enough to get you guys started just thinking about what happens. Like here, even in number 4, they're asking you what happens when you take 180 minus your theta. So again, just realizing that these values are the same if whatever theta is, this is 180 minus theta, right? So you wind up with the same value, the same triangle, excuse me, in both quadrants. All right, so take a look and see if you guys can work through some of these in section 8C. Otherwise, have a wonderful break. If you've actually watched this entire video over your break, ask Miss Bush or myself for Fredo Frog, because you deserve it. All right, have a great break. See you guys later.